back to our channel. Today's session we will go with another sorting mechanism that is called a quick sort. So this sorting mechanism will follow the divide and conquer method. Divide and conquer. So the name itself indicates. So divide and conquer means first the complex problem is divided into sub-problems and each sub-problem will be implemented. So like that here also the complete large elements will be divided into different partitions and each partition will be applied for sorting technique. So each partition will be implemented by using the recursive methods. Okay. Next, so let us see the procedure first and then we will go with the example. Then first step, here we have to select the pivot and we have to find the position of the pivot element. So here we will go with the pivot element, right? So first we have to find the position of a pivot. Position of a pivot such that all the elements which are left towards this pivot are less than the pivot element, and whatever the elements which are on the right side to this position are greater than a pivot, right? So this position, first we have to find this position, then consider this as one partition, consider this as another partition. So see, this is less than pivot, this is a greater than pivot, don't get confused. Okay, this is a less than symbol and a greater than symbol. Okay, so less than pivot is one partition, greater than pivot is another partition. So recursively call the same procedure for this partition. Again consider a pivot and find the position of the pivot for this partition and again divide that into two positions, right? So like this we have to find this quick sort. First, this pivot can be considered as the pivot element can be considered as first element, middle element, last element, right? So we can consider any element as a pivot element, and based upon that pivot element we have to find the position of that particular pivot element, right? For example, if the numbers are 10, 50, 40, 10, 30 and 20, this element can be considered as a pivot, or this element can be considered as a pivot, or this element can be considered as a pivot. So after considering the element as a pivot, we have to find the position of that particular pivot point such that all the elements which are less than pivot should be on the left hand side, and all the elements which are greater than the pivot should be arranged on right hand side. So in such a way we have to find the position of the pivot. First we have to consider the pivot element. What is the pivot element, right? So in our example we will consider this one, first one. So let us consider the first element as a pivot and find the pivot position. See, first consider first element as a pivot. Consider the first element as a pivot. Next, initialize I to low index, j to high index. That means a starting element, j is a last element. Next, we have to repeat the procedure. repeat the following steps until I less than j. So until I becomes until I less than j, until the condition is true, we have to repeat the following procedure. So first, keep on incrementing I while a of I is less than or equal to pivot. So unless this condition becomes false, we have to keep on incrementing the I value, right? Next, similarly, keep on decrementing the j while a of j is greater than pivot. So similarly, from the starting, we have to incrementing the I towards the right, and we have to decrementing the j towards the left. Okay, so while incrementing and decrementing I and j values, we have to check these conditions, whether a of I is less than or equal to pivot, and whether the a of j is greater than pivot, right? Next, so if this two condition fails, if these two at some condition, this condition, I mean at some point this condition will be failed, so we have to stop incrementing the I. At some element, this condition will be false, so we have to stop decrementing the j. Now check the condition. If I is less than j, yes, then if it is true, then swap the elements a of I, comma a of j, a of I, comma a of j. So we have to swap the elements of I value, the elements which are available in ith index and jth index. Next, if this becomes false, I less than j. So if I is greater than j, the index value of I is greater than j, then also we have to swap a of j element with the pivot. So this is nothing but, this is nothing but a of low, because here the pivot is the first element, right? Pivot is the first element. So we have to change the swap between the jth element and pivot value. So here j is the position of pivot. So this is very important thing, right? J is the position of a pivot, so that all the elements which are less than pivot are on the left hand side, and all the elements which are greater than the pivot will be on right hand side. So here, after completion of this one, the pivot value will be fixed. The pivot position is fixed, right? Not the pivot value, pivot position will be fixed, right? So we are supposed to find that position of a pivot. Now divide the two partitions. So one is after getting the pivot value, right? So this is one partition and this is another partition. So this is 0 to p minus 1, and here p to high, p plus 1 to high. Okay, p plus 1 to high. Instead of writing 0, so we'll write a low, right? Low to p minus 1. So this is one partition, this is another partition. So consider this partition, and here also consider repeat the same process. So recursively repeat the same process. Consider this partition as a array of elements. Now consider the pivot, first element as a pivot, and starting I to low index and j to high index. So I will be low, j will be p minus 1, and then repeat the following steps until I less than j. So keep on incrementing I while ia of I is less than or equal to pivot, and then keep on decrementing the j while a of j is greater than pivot, right? Then if I is less than j, the index values of I is less than j, then simply swap the positions of I and j, the elements which are at positions of I and j. Then if I is greater than j, the index value of I is greater than the index value of j, then simply swap the low value with the a of j, that means of the value present at the position j. So here a of low means nothing but a pivot value, because in the first step we are considering the first element as a pivot. So here again the pivot, the position j is the position of pivot. So position, when the pivot position is fixed, so that all the elements of which are less than pivot will be on left hand side, and all the elements which are greater than pivot are available in the right hand side. And again do the partitions and again repeat the same process, right? So this is how we will implement, we are going to implement this quicksort, right? So based upon this algorithm, let us solve an example so that your doubts will be clarified. So our aim is to find the position of a pivot, and we will implement the same thing recursively for all the partitions. So once the pivot is fixed, then we have to divide it into partitions, and considering each partition, and we have to repeat the same. Okay. Example. Let us take some elements. Consider these elements. Okay. See, so these are the elements of an array. So this is array elements. These are the indexes. This is the I value. This is the j value. I value, j value. Okay, right. Then consider this as a pivot. Consider this element as a pivot. Now repeat the process. So first step, consider the pivot as a first element. So we have considered this one, and next I is initialized to low and j is initialized to high. So I less than j, that is here 0 less than 5. The condition is 2. So this condition is 2. We have to repeat the process. So what we have to repeat? We have to keep on incrementing I until a of I is less than or equal to pivot. So a of I less than or equal to pivot. See this condition I plus plus. We have to repeat the same process. Okay. So here see first 30 less than or equal to 30. So I plus plus. So that means 1 it will be. Next 20 less than or equal to 30. I plus plus 2. Right. Next 10 less than or equal to 30. I plus plus 3. Index value 3. So 50 less than or equal to 30. So fails. Okay. Fail. Here the fail. Condition fails. Now here at what condition it is failing? I is equal to 3. So I is equal to 3. Right? Condition I is equal to 3 fails. So after completion of this one, I is pointing at here. Okay. Now keep on decrementing the j value. So a of j is greater than pivot if I j minus minus. So repeat this process. So a of j is nothing but a high value, high value 5. So 40 greater than or equal to, greater than 30, j minus minus, so it will be 4. Next 60 greater than 30, j minus minus, it's again 3. After decrementing it will be 3. Next 50 greater than 30, again j minus minus 2. Next 10 greater than 30, fails. So at where it fails, j is equal to 2, right? So at some condition, at some element, both the condition will be fails. Now we have to check whether I is less than or j. So what is the, see, if I less than j, then swap a of I element with a of j element, right? Else we have to change, swap a of j element with pivot, right? Now let us check the condition here. So I less than j, so 3 less than 2, I less than j, 3 less than 2, which is false, right? So we have to swap a of j. A of j means, see, j is 2, a of 2 comma pivot. What is the pivot? 30, or a of low, okay, a of 0, because here the pivot is a of 0, right? So swapping j position is pivot. So what is the j position? 2. Second position is a pivot element. Second position is the pivot element for the first thing. So after getting this one, see, just swap the positions, a of 2 comma a of 0. A of 2 means 10. So 10 will be here, 20, then 30, then 50, 60 and a 40. See, 0, 1, 2, 3, 4 and 5. So second position is a pivot. Second position is a pivot, right? So here if you observe, all the elements which are on the left hand side of the pivot are less than this pivot, 10 and 20. So it may be in a sorted order, or it may not be in a sorted order, right? So whatever the elements which are on the right hand side of the pivot are greater than the pivot elements, right? So this may be in a sorted order and this may not be in a sorted order. So this is the partition 1, this is the partition 2, right? So now we have to consider, so this position is fixed, right? Pivot position is fixed. So we have to take care about the partition 1 and partition 2, excluding this pivot position. So that's why we are writing from 0 to low to p minus 1, and here p plus 1 to high. So we are not considering the pivot position because it's already fixed. So hope you understood this one. So after the first iteration, first recursion, this is the elements. Now let us write these elements, okay? I will write down here. So 10, 20, 30, 50, 60 and 40. Right. So I will erase all these things. So first recursion, this is about the first recursion. Now So this is the pivot element, okay, fixed. So this will be the partition 1 and this will be the partition 2, right? So let us consider these partitions. So 10 and 20, 0th index, first index. So obviously this will be I, this will be J, and also pivot. We know that we are considering the pivot as a first element, so this one. So what we have to check? We have to repeat until I is less than J. Here it is 0 less than 1, condition true. Then keep on incrementing. So A of I is less than or equal to pivot I plus plus. So for this we have to go with this. So 10 less than or equal to 10, I plus plus, that will be 1, and 20 less than or equal to 10, okay, so false. So I is equal to 1, right, I is equal to 1. So I value is changed from here to here, okay. Next, A of J greater than pivot, we have to keep on decrementing the J value. We have to keep on decrementing the J value. So 20 is greater than or equal 20 is greater than 10, J minus minus, right? J minus minus, and the value will be 0 now because initially J is equal to 1, and 10 is greater than 20, which is a false. So J is equal to 0. See, at I is equal to 1, the condition fails. At J is equal to 0, condition fails. Here, if you observe, I is less than J, then what we have to do? Swap A of I comma A of J. Else, we can write the condition, okay, I greater than J, then swap A of J comma pivot, right? Pivot, right? So here we can observe here at what positions the condition fails. I is equal to 1 and J is equal to 0. So 1 less than 0, the condition is false. So this will be happened. So swap A of J means 0 comma pivot. Here pivot means again A of low. So that implies so both the J position, both the J value and a pivot are at the same position, so we need not swap anything, right? So already those are in sorted order. That means these are in a sorted order because we need not swap any element. Okay, only two elements are there. We need not swap any element. So this will be the pivot position. Okay, so here see, J position is a pivot position, isn't it? Right. What is the J position? 0. So 0th is a pivot position. If 0th is a pivot position, see, left hand side we are not having any elements. Right hand side we are having only one element which is also greater than 10. So it implies this partition is already in sorted order, right? Next, hope you understood. Next we will go with the partition 2. We will go with the partition 2. So this is already in sorted order. Now we will repeat the same process with the partition 2. So 50, 60 and 40. So 0, 1 and 2. So this is the I value, this is the J value. Okay, this is the I value, this is the J value, and this is the pivot. Right. So continue the process. So I less than J, that is 0 less than 2. So this condition true, then a of I less than or equal to pivot I plus plus. So keep on doing all these things. So a of I, that means a 50 less than or equal to 50 I plus plus, that means I becomes 1, initially 0. Next, 60 less than or equal to 50 fail at I is equal to 1. At I is equal to 1 it fails. So now I becomes here. Then similarly a of j is greater than pivot j minus minus. So repeat this process. So j value is 40, 40 greater than 50, 40 greater than 50. Condition false. So at j is equal to 0 position. At j, at j is equal to 2. At j is equal to 2, the condition fails. Okay. Then see, if you observe here, check the condition I greater than j. Here I is 1 greater than 2. I greater than j. It is a false. So swap. I'm extremely sorry. I less than j. So if I is less than j, we have to swap the elements a of I and a of j. If I is greater than j, then we have to swap the elements a of j and pivot. So here the first condition, I is less than j. I value is 1, j value is 2. So I is less than j. So swap a of I comma a of j. So what are the elements we have to swap? Swap the 60 and 40. So the elements will be, after the iteration, the elements will be 50, 40, 60. 50, 40, 60. The positions of I and j are same. Okay. So the index values 0, 1 and 2, and this is the pivot we are considering. Right. So after swapping 60 and 40, we will get this one. Okay. Now again repeat the same process. So a of I is less than or equal to pivot. So I plus plus. Consider this one. A of I, that means a 40 less than or equal to 50. I plus plus, which becomes 2. Similarly 60 less than or equal to 50 fail at I is equal to 2. Right? At I is equal to 2 it fails. Now I and j are positioning at the same point. I and j are positioning at the same point. Similarly a of j is greater than pivot, then simply decrement the j. Repeat the process. So 60 greater than or equal to 50, not equal, greater than 50, j minus minus, which becomes 1. Similarly 40 greater than 50, which fails at position j is equal to 1. Now j is positioned at 1. Right? Now check the condition. So if I is less than j, then swap a of I comma a of j. Just a minute. Else swap a of j comma pivot. Right. Now here I is 2, j is 1. 2 less than 1, false. So we have to swap, false condition, swap a of j comma pivot, which is nothing but swap a of j means a of 1 40 comma a of pivot 50, and we know that j is pivot. J is pivot, that means 1 is pivot here. Okay, so here 1 is pivot. So after completion of this, Okay, after completion of this, so I will erase this one. Okay. Right. So here J is a pivot. J is pivot. Here what is the value of J? 1. So 1 is a pivot position. 1 is pivot position. So we have to swap. After swapping 40, 50, the elements are 40, 50 and 60. The positions 0, 1, 2, the position, this is the pivot position. So left hand side of the pivot is having the values less than pivot, and the right side of the pivot position are having the elements greater than pivot. So here again, this is the one partition, this is the another partition. So here the partition is having only one value, so need not apply the sorting technique. And here also the partition is having only one value. Here also we need not apply the sorting technique. So finally, after completion of all these things, we can simply have (40, 50 and 60). Okay, so this is a procedure we are supposed to apply. So hope you all you understood this one, right? After the first iteration, 2 is a pivot, so that 2 partitions are there. First partition, again 0 is the pivot. Second partition, 1 is a pivot. 1 means the position 1, index 1. Okay, index 0 and index 1. Right? So hope you understood this one, the quicksort algorithm, how it apply for this, how we are dividing the complete elements into different partitions, and how we are applying the recursive functions. Right? So simple thing. So first we have to consider the pivot element, and first to find out the position of that particular pivot element, and then based upon that particular pivot element we have to divide it into the partitions and recursively apply the same procedure. Now we'll see the time complexity of this quicksort, and hope you enjoyed the example and the algorithm, the procedure, how we can sort the elements by using this quicksort using divide and conquer. Now we'll see the time complexity. So the time complexity of this particular quicksort is, so we are selecting the pivot element and we are dividing the complete elements into 2 partitions. Okay, 2 partitions. So one partition, let it be the pivot element is a middle element, right? So obviously it will be T of n by 2 plus T of n by 2. So worst case, let it be the pivot element is a middle element. So what we are doing, we are dividing the complete elements into 2 halves. So from 0 to, low to mid minus 1 and mid plus 1 to high, because the middle element will be the pivot. So we need to sort out all the elements of left partition and the right partition. That means pivot left of the pivot and right of the pivot. So this way. And for everything, for every partition we have to do some n comparisons, because we are applying the sorting up, right? So we require n comparisons, so n. So finally we can write it as 2t n by 2 plus n. So this will be the complexity. Now for the next iteration, so the half partition, again it will be divided into 2 halves. So then if it is n by 2, then 2t of, apply 2t of n by 2 divided by 2 plus n by 2 plus n. So we are applying only this one, right? So t of n is this one, t of n by 2 is this one. And if it is n by 4, what happens? See, before applying the n by 4. What's the resultant here? So 4t of n by 4 plus n and n, that will be 2n. And if it is n by 4, what happens? And that means again we are dividing the complete elements into two halves. So if it is n by 4, then again it will be, so 4 into 2t of n by 8 plus n by 4 plus 2n. So then what happens here? 8t of n by 8 plus n, okay, plus 2n, that it will be 3n. So this will be the thing, and this will be continued, okay, this will be continued. And what is the stop conditions? Here also the most important, stop condition. From that only we will get some values. So we are dividing the complete elements into halves, and we are repeatedly doing the same thing until we get one element. That means n by 2, n by 3, sorry, n by 4, n by 8, n by 16, and so on, n by 2 power k. And when it will be stopped? Whenever this becomes 1. That means whenever the partition becomes one element. So from this we can write it as n is equal to 2 power k and k is equal to log n. So this is the most important, because from this only we are supposed to calculate this n and substitute the n and k values. So in general we can write it as, so t of n is equal to, so 8, that means 2 power k, okay, or simply we can represent this one 2 power 3 into t of n by 2 power 3 plus 3n. So in the generic we can write this one as 2 power k t of n by 2 power k plus k into n. So we can write the complexity in a generic format like this one, 2 power k, right? Now you can substitute the n value and k value here. So 2 power k, what is it one? N into t of n by n plus k value log n into n. So this becomes n into t of 1 plus n log n. So you can know that if there is only one element, so we need not do all the procedure, the complexity will be 1, because the element itself will be in the sorted order, because we are not having more elements, right? So we are having only one element, so obviously we can say that will be in the sorted order, right? So there is no comparisons. So obviously this becomes 1, so n plus n log n. So in this equation we know the highest degree is n log n. So obviously the time complexity of quicksort, t of n is equal to big O of n log n. So this is the time complexity of the quicksort algorithm, right? So hope you understood. So we are just dividing this one, and this is most important in every time complexity calculation. So from this only we are going to substitute these n and k values. So we are keep on dividing the partitions. So this is a complex problem. So after first iteration we are dividing the problem into half, and this process will be repeated until the partition elements becomes only 1. So from that we got n value and k value, and we are substituting the same in this particular time complexity, right? So let's stop here. Hope you enjoyed the complete working of a quicksort. So we have seen the example algorithm, and now we have seen the time complexity. So if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session,
like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.